Thanks, Parker. Baby. Thank you, Rana. Thank you, Lisa. Thank you, Lisa. Thank you, Lisa. All right, so I do want to start, so I need your papers up here, please. Yeah. Thanks, man. Okay, so we need to take a little bit more notes today. Yesterday we were adding and multiplying, dividing, and now we're solving complex polynomials. It's logical. Did I do okay? Oh sure, yeah, I'll do it. I'll put up the answer key for it. Yeah, but I do want to get through these notes today, so. How do we solve these kind of equations? Z to the n equals some number c. N is a positive integer, c is a complex number. These are called the nth roots of a complex number c, nth roots of a complex number c, or the n solutions of z to the n equals c, right? So you're going to get n solutions for this kind of an equation. Z to the n equals c, you're going to get n solution. We're looking for the nth roots, right? So that's what we're doing today. Sometimes you can do this by factoring. Sometimes you can do it an easier way. Well, it's actually much easier, using this method called nth roots. So, just for old time's sake, solve this one by factoring, and then also solve it by, well, do it by factoring first. Let's try it together. So maybe that looks confusing. Z to the fourth minus 1 equals 0. That factors. Z squared minus 1 times z squared plus 1 equals 0. Z squared equals 1. Z squared equals negative 1. Complex number squared gives me 1. Well, two numbers that do that. 1 and negative 1. Z equals 1. Z equals negative 1. Two complex numbers squared gives me negative 1. Z equals I. Z equals negative I. Make sense? Okay, so factoring. That one was pretty easy. And now let's try it also this way. Nth roots method. So let me make sure I have my ideas right here. Is this the one? Yep. Here's another way you can do it. Z to the n equals 1. Well, rewrite this as 1 CIS. What would the argument have to be? What would give me 1 for a complex number? Argument would have to be 0 or 2 pi, right? Okay, so this is 0 plus 2 pi times some number k. Right? It doesn't matter. We can go over however many times, right? We still go back to 0. But we're only going to look at it for k equals 0, 1, 2, and we're doing up to 4, so we have to go up to 3. This is an important setup, all right? I would star this because, I don't know, I didn't really do this much. Really, this was like the first time I had even seen, this class was the first time I had seen this notation, and yeah, so a lot of new stuff for me too. Trying to solve this, let's see, take the nth root, is that correct? Yep, we're taking the 4th root. 4th root of both sides, because we're talking about z to the 4th. So, let's do that. That's equal to, if you take the 4th root of the left-hand side, you get z. If you take the 4th root of that, you get CIS of 2 pi k to the power of 1/4, right? Because we took the 4th root. Well, you can use properties that we know. How can I simplify that? Yes. Yep. So put that down there in the argument. Z equals CIS. 2 pi k over 4, so that's pi k over 2. All right. And I'm going to evaluate that for 0, 1, 2, and 3. Z equals, if I plug in 0, pi times 0 over 2, so that's 0, CIS of 0. If I substitute in 1, CIS, yep, CIS, let's see, 1 times k, so that's pi over 2. If I substitute in 2, CIS, let's see, right here, goes away, so I get pi. If I substitute in 3, CIS, 3 pi over 2. Now, if you look at these, right, cosine I sine theta of 0, well, the I sine theta goes away and you're just left with 1. Cosine I sine theta of pi over 2, cosine goes away and you're just left with I. Yep. Cosine I sine theta of pi, -1, sine goes away, you just get -1. You see how these match up? Yep. Which way do you think is easier?
First one was easy for this example, but I feel like for other examples, the new one would be easier.
Yeah. Some polynomials, right, just unfactorable, and some of them are just really hard to factor. So this method, you want to start this one. This is important. All right. Well, you try it then for this one. See if you can do it. Find the 4th roots of -4. What that means is set up this equation. 4th roots of -4. See if you can do that together. Give it a try. This one, I'll just kind of go slower as you are working through it. It might not be clear that that's equivalent, but if you do cosine of pi, what do you get? -1. That gives you a -4. Do you see how these two are equivalent? Mm-hmm. Yeah. So that was tricky, right? Let's see, next step. 4th root both sides. took the fourth root of both sides, and we simplified using, whose property was that? I forget. Was that it? Oh, I like it. I don't have that pronunciation now. That's why I let other people say it. All right. And it's important to know what we're evaluating for. K equals what? 0, 1,
1, 2, 3.
Yep. You go up to 1 less than the nth number. 0, 1, 2, 3. So evaluate. Well, let's simplify this guy first. That's 2 squared to the power of 1/4. So that's 2 to the power of 2 over 4. So that's 2 to the power of 1/2. So that's square root of 2. So that's just mental math. Evaluate. I'll do 1 by 1. Substituting in 0, you get CIS of pi over 4. Substitute for 1, 2 pi plus pi over 4, so that's 3 pi over 4. Another one, 4 pi, 5 pi over 4. Last one should be what?
7 pi over 4.
Square root of 2, CIS, 7 pi over 4. Okay. It did ask us to find the fourth roots of it. We found them, but maybe also for just some extra practice, let's convert them to different forms. Right? Let's convert them.
Why did you use -4? Why did you use 4 instead of -4?
So if I use -4, then that would be what? -4 CIS 0 plus 2k pi. Right? Cosine of 0 is 1. -4 times 1 is -4. You should go through and we should get the same thing. I haven't done that, so there might be an issue there. I'll double check. I'll go through that and we'll talk about it tomorrow, but you should get the same thing, because this is equivalent to this, right? Cosine evaluated at 0 is 1, -4 times 1 is -4, 4 times -1 gives you the -4. So it'd be a good thing to check. See if you do come out with the same thing. You'd have to work with imaginary numbers out here, because fourth root of -4, right? So. All right, but let's finish off this one. See if you can convert those before you leave. Right? See if you can convert those both to Euler form and Cartesian form. Because then we want to plot them. So, unit circle comes in handy here. So 4 minutes so we can finish this. Is it 1, 2, 3, 4, 5? So that's negative, negative. Negative square root of 2 over 2 minus square root of 2 over 2 I. Last one should be positive, negative. Do you agree with those? Yeah. We can simplify further because we'll distribute, and that becomes what? 1, 1. So this is 1 plus I. This is -1 plus I. That one is -1 minus I. That one is 1 minus I. Right? Just distribute the square root of 2. And then you can graph them, and you'll see something interesting. Right? They're all going to lie on a circle of radius, absolute value of this number. They're going to all lie in a circle with the absolute value of that, so they're going to all lie in a circle with, is that correct? Let's check. Square root of 2, right? 4 to the power, yes. Yeah, so radius that, right? Very good. Yeah. So 1 minus I, graph that one. 1 minus I. Negative 1 minus I. Negative 1 minus I. Let's see, negative 1 plus I. Negative 1 plus I. And 1 plus I. 1 plus I. All right. Make sense? Good. I think this is kind of a tricky section, so I think it would really benefit you, especially if you find yourself having trouble with this one. Read through that section. It's not very long. It's not very long, and it's going to be redundant because it'll be doing some of the problems that we just did today. So I think that'd be a good thing to do if you're having trouble with this section. Is anybody struggling right now? So I can know. Yeah. Thanks for being honest. Anybody else struggling with this one? Yeah. A little bit. Yeah. It's a little tough. I agree. So that's why we'll take it slow, and then we got one more page of notes to do tomorrow. Yeah. Again, can't emphasize that enough. You should try and read it. Yeah. Oh, those are just the vectors. Say it again.
Well, pi over 4 and negative pi over 4.
Correct. Oh. Let's see. 7 pi over 4.
That's right there. Negative pi over 4.
And yeah, I'm just thinking in my head, CIS 7 pi over 4, right? So that's cosine 7 pi over 4 plus I sine of 7 pi over 4. So that's, let's see.
It's like right here, right?
Right.
And then pi over 4 is also like right here. So
Negative pi over 4.
yeah, negative pi over 4.
Yes.
So it's-
Oh, they are.
Oh, they are?
Yeah, they're equivalent.
Gotcha. I was just confused whether it was
Here, coming up. Let me see. Are you saying this one?
No. These two, aren't they the same? So it should just be here.
Well, this one's 7 pi over 4. So 1, 2, 3, 4, 5, 6, 7.
Yeah, and that one's the same as negative pi over 4.
Right. But then this one is 5 pi over 4.
Yeah.
1, 2, 3, 4, 5.
Yeah.
This one's 1 pi over 4.
Yeah.
And this one's 1, 2, 3.
Oh, is there no negative pi?
No, yeah. No negative.
That's what I was saying.
Yeah.
That's why I was like, oh, that's really nice. And that's what I was confused. Like, pi over 4 and I'm like, it's the same.
Yeah.
Oh,
Yeah.
I'm confused.
So you, okay, so you see these?
Yeah.
What is it? A and C? Huh? That was right now. That was right now. Oh. You were in the bathroom. Do you want to write down it? It goes into fourth period and yeah. So I mean, you're more than open to go down. Sorry, you went to the bathroom and you came back. Yeah, you went down. I'm sorry. You can go grab lunch, bring it down. Where you going? There you go. Sorry about that. Where you going?
Period 4 teacher. I did it back in Spanish teacher.
I think if you have that pass, you're good. Or, oh, wait, we're supposed to get started. I think they'll understand. I mean, it's really important. I can't do it.
Is this one of your
Do they offer a calculator?
Here, take one. Let's get this.
I don't know if that was Jack's or it's left on the table. So.
Oh, yeah. No, he borrowed one.
Oh, you borrowed one. Sorry.
Yep. Sorry, Jaden. Have a good day.
So did, so that's what they're saying. but not me. Oh, you have first one? If you see Lexi, you ask her, Lexi, yeah, if you hear, ask her how much money she got from Miss Noah's class at St. Patrick. Do you have your phone?
Oh,
Is it dead?
I can ask someone. I'll write it down.
Okay. Just
Oh.